Hello. All right. So today we're going to start on vocabulary word number 28. Let's talk about the word perpendicular. Perpendicular, these are two lines or two segments or two rays that form a right angle. All right. Now, there's a symbol for perpendicular. I'm going to put it over here. It's an upside down T. All right, you don't need to have the parentheses around it, but that's what it's, upside down T. All right, so let's draw a couple of these problems. If we draw two lines, and the easiest ones is to draw one vertical line, one horizontal line. When a horizontal vertical line intersect, they will be perpendicular to each other. So we'll put the box in the corner. Now, if I call one of these lines line L, I'll use a lowercase l. And the other one, I'm going to use a fancy M. Then the way I would write this is I would say line L is perpendicular to line M. We like that there's a symbol for this word because it's a really long word. All right, it might be two segments. So the picture would look very similar to this, but without the arrows. There would just be points at the end. Two rays are going to look like just one right angle, like that. Okay. If we want to show perpendicular planes, let's use our box. Yeah. And I'm going to use the one in the front. So all these corners, actually all the way around. Put one up here too. All right. The ones on the sides don't look like they're right angles, but they would be, right? We would have right angles all over the place. Okay. Now let's name these. Let's go around. So we've got A, B, C, D, E, F, and actually that's enough letters. So if I want to focus on this front face and the side face, I know that they are perpendicular, that is a right angle right there. Okay, so I could say, remember 3 letters to name a plane, so I'll call this one plane AFE is perpendicular. And then 3 letters for the side one, I could use CDE. And that's how we would name the plane. Okay. Bisectors. There are 2 kinds of bisectors that we can work with. They are perpendicular bisectors and also angle bisectors. Let's talk about perpendicular bisectors first. A perpendicular bisector, again, could be a line. It could be segments, or it could be rays. That is both, notice it has to be both perpendicular and it has to go through the midpoint of the segment. So let's start with drawing a segment. We'll call this AB. And let's identify the midpoint and we'll call that M. Now remember, to identify a midpoint, we have to show that we have 2 smaller congruent segments. Now, we've talked about a segment bisector before, which could be a line, a segment array that passes through this. But if it's going to be a perpendicular bisector, then it must not only go through the midpoint, but it must also be perpendicular and form a right angle. All right, so I'll call this line L. And then over here, so we would say line L is a perpendicular bisector of segment AB. All right, so it must go through the midpoint and it must also form a right angle. All right, an angle bisector is going to be a ray that divides an angle into two congruent angles. All right, so just sketch a big angle to start. Now, in order to be an angle bisector, we're going to kind of eyeball where the halfway mark is, and we want our ray to go up through that. So when we're done drawing that interior ray, not only do we have two smaller ones, but we can mark them, the arcs up here, the same. And then we can say that angle 1 will be congruent to angle 2, or we can say the measure of angle 1 will equal the measure of angle 2. Okay. Now, the day before we talked about linear pairs and vertical angles. There are two rules that go with them. The linear pair postulate says that if two angles form a linear pair, then we know that they are supplementary. All right, we also talked and reviewed supplementary yesterday. And supplementary means that they are going to add to equal 180. All right, so the postulate though says if you have a linear pair, they are supplementary. So notice in our picture, we've got a linear pair. One of the angles is 80, the other would then need to be 100. So obviously 80 plus 100 is 180. I'm going to add degree signs to these because they should always have degree symbols. Okay. Vertical angles, these were the angles that were opposite each other. So if two angles are vertical angles, then they are congruent, always. Right. So you can see in this picture, we've got two vertical angles. Those would both be the same measure. In this picture, they're 40. And then the other pair would also be the same measure. These are both 140. All right. And remember then, the two adjacent angles in a picture like this form a linear pair. So that's, we can check. So 40 plus 140 equals the 180 using our rule above. Okay. Let's do a couple examples together to finish out the notes. All right, you're going to be asked to do some problems like this where it says solve for angles 1, 2, and 3. All right, so just to set myself up, I need to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. All right, the easiest one usually is just to identify your vertical angles, the ones that are opposite. So I know that the measure of angle 2 is going to be the same as the 67 degrees. All right, the 67 degree angle and angle 1 are adjacent, so they make a linear pair. So the math I'm going to do to get angle 1 over here on the side, I simply need to do 180 minus 67, and that will get me angle 1. So I'm going to have 113. So over here I could write 113 degrees, and since 1 and 3 are vertical, then angle 3 will be the same. Done. All right, now we're going to throw some algebra in there. So the second example wants us to solve for x. The first thing you need to recognize is what relationship do they have? Are they vertical or are they a linear pair? All right, so you want to ask yourself vertical or linear pair. These happen to be vertical. Well, what do we know about vertical angles? We know vertical angles are congruent. So that means they have equal measure. So that means that 3x is going to equal 2x plus 16. That's how I would set that equation up. I want to set them equal to each other. And then we solve the equation, right? So I'm going to subtract 2x. So I get x equals 16. That was all we were asked to do, so we're done. In the last example, again, you want to always ask yourself, what's the relationship? Are these vertical or is it a linear pair? Now I'm writing these down. You don't need to do this. You can think these in your head, but these are our notes. So the relationship between these two, since they are adjacent, these are a linear pair. So what do we know about linear pairs? They are supplementary. Supplementary angles add to equal 180. So I'm going to do 15t plus 20t plus 5 and set them equal to 180 degrees. Combine your like terms. So I really have 35 t's here on the left, plus 5 equals 180. And then I can start going side to side. So 35t equals 175. And then to divide that out, I'm going to get okay. All right. You can now complete the assignment and don't forget to come to tutoring if you have any questions.